Hello, and thank you for being with us here at Couchbase Connect. In this session and talk, we'll speak about the cloud exploration that we've been doing here at Amadeus Loyalty. So in 1 hour or so, you will get out of this talk knowing a little bit more about our company, Amadeus, knowing much more about the loyalty business for airlines, and especially what makes frequent flyers so important to airlines, especially those days. And then you will have a detailed sense of the performances that you can expect from Couchbase, thanks to some benchmark that we've been doing over the cloud. My name is Laurent Dolé. I'm an engineering manager at Amadeus Loyalty, and Eric Robert will help me on this presentation. He's lead software engineer at Amadeus Loyalty as well. So let's talk about Amadeus, our company. We are the leading technology company dedicated to the global travel industry. So we are present in almost 200 countries all over the world, and we are helping passengers being boarded every year, millions or billions, the good years of passengers being boarded thanks to our systems. Where exactly are we helping you travel? Well, pretty much all over the place and in every step of your traveler journey. So whether you are getting some inspiration, wondering where you should go for your next holidays, whenever you are shopping your tickets, booking for your flight, before, during, after the flight, renting a car, all over those steps, we are here to help, and we are here to provide IT solutions to our partners. I like to refer to our customers because that gives you as well a good sense of how global we are as a company. Our customers, they could be traveling agencies, online travel agencies, airlines, a lot of them, airports, ground handlers, hotel properties, rail operators, car rental companies, insurance, cruise and ferry lines. So again, all over the travel industry, Amadeus is here to help. And that very last slide, I like it very much because it speaks about technological evolutions and what's the history of our company. So we've been founded 30 years ago, let's say, by 4 major European airlines, Air France, Iberia, Lufthansa, and SAS. And we started on mainframes. But since then, we've designed new architecture based on open source systems, so Unix, focusing as well on relational databases and migrating to Oracle. And we've invested a lot, several billions of euros in R&D all over those years. And we are continuously evolving as a company. So we've launched our open source initiative. We've introduced NoSQL databases 8 years ago, and since then we've won a lot of awards, right? MongoDB, Red Hat, Cloud Innovator of the Year, and very recently we've opened what I like to refer as our 3rd chapter, right? We are now moving from a private data center to the public cloud. And Couchbase is helping us as well in this 3rd chapter. So we have signed a partnership and extended it very recently with Couchbase. And Microsoft Azure is our preferred partner for everything related to cloud services. So we are implementing and designing right now at Amadeus Loyalty an open and modular platform. Before talking about what exactly we are doing and how we are doing it, let's talk about why. In Amadeus, we like to focus on our customers and their business. So let's focus on loyalty programs, right? And especially those years, it's very interesting to focus on loyalty business in the airlines industry because of the pandemic and because of those challenging months that we've been going through, right? And you may be surprised to actually know and understand that the airline survival may actually very well depend on those frequent flyers, on you and me, basically. So let's focus on 3 big airlines, American Airlines, right? Delta Airlines, American Airlines, United Airlines, and just have a look at the airline overall valuation, right? Those airlines are worth billions of dollars. Now let's focus on the valuation of their loyalty programs. So in case Delta Airlines wants to sell its loyalty program, that's the price they would sell the loyalty program for. And it's what's very surprising is that, for instance, the loyalty program for American Airlines is worth 4 times the cost of the airline itself. So in contrast, what can we understand? The airline operation is worth nothing or almost virtually a negative value, right? All those planes, all those slots on the airports, that world-beating maintenance, the brand recognition, all this is virtually worth nothing. And what is worth at that particular moment in time, in 2021, is the loyalty program. So I'm not saying that that airlines should sell their loyalty for some quick cash, right? What you have to understand is that loyalty and airlines and airline operations basically are both of them part of a unified business, and the two are needed to make it viable. So loyalty program need the airlines to attract customers or members, and airlines need loyalty to make the whole process viable from a financial point of view. If you need another evidence about why loyalty programs are important, all those 3 airlines have contracted $7 billion worth loans last year, and the banks have asked all those airlines to secure the loans against the loyalty programs again. So, okay, investors are telling us loyalty programs are definitely important. That's the view of the bank, right? Why is that? Let's take a look at United Airlines. Their loyalty program is called MileagePlus, and let's take a look at the margin of the loyalty program all over the years. As you can see, that's the blue line in front of you. The margin of the loyalty program has been very resilient, very stable all over the year. An airline can have good years, bad years, but the loyalty program acts like a cushion, a buffer, right? And this long-term track record of stable financial performance is what is attracting investors. So we could ask ourselves, what are the mechanisms that makes this possible? You'd be very interested to know that by design, a loyalty program can ensure a very stable performance. And so let's take a look at exactly what is a loyalty program. A loyalty program, it's very simple. It's a points bank, right? It's a bank in which you have points. And whenever you get points, someone is buying those points for you. So it means when you are earning points, cash flow is coming on the loyalty program's pockets. Then at some point, you want to use those points to buy a night at a hotel, and access to a lounge, etc. When this happens, that's what we call a redemption. You redeem your points, again, a free benefit. Then the money is getting out of the loyalty and is getting to the hotel, for instance. So you have those two mechanisms, right? Let's take a look at the miles that people have earned and the evolution between 2019 and 2020. As you can imagine, the miles that have allowed people to earn points have decreased tremendously. Last year, a lot of flights have been grounded, so only 3% of the usual amount of miles have been used to allow people to earn points. So now let's consider this and the consequence of this, and let's look at the cash flow. You could wonder and you could imagine that the cash flow would have been decreased by 97% as well, but that's not true actually. And why is it that the cash has decreased but not so much? It's because members have continuously engaged, even during the pandemic, with third parties, so non-air partners. And this is protecting the incoming cash flow for loyalty programs. So people have continued, for instance, to use their co-branded credit cards, even during the pandemic. And this is helping loyalty programs. So you can imagine that for people running the loyalty programs, diversifying the activity, diversifying the non-air partners is something that is very, very interesting. And we've been asked to make this ecosystem of partners very vivid, especially those days. And now let's focus on the miles that are burned. So when you burn points, it means you use those points to buy, or not to buy, but to get a free ticket, right? That's the free ticket that everybody loves to get. Let's consider the difference between 2019 and 2020. As you can imagine, a lot less of flights have been in the air last year. So a lot less people have used their points and burn their points to use to buy free tickets. Okay. But now there's another mechanism that you need to be aware of. What happens when a flight gets cancelled? Especially what happens if you use a free ticket to book a flight and the flight gets cancelled. Then we have what we call the return of miles. The miles are returning back to the loyalty program, and it means the airline are paying back the loyalty program, and you have again cash flow coming into the loyalty program's bank account. Last year, you had more miles returned, cancelled, than miles burned. Again, for United Airlines. So instead of having a negative cash flow, that's what we have the usual years. Loyalty program providing United Airlines with money in exchange for the free tickets. Last year, we got a positive cash flow for the loyalty. So at the end of the day, and from a pure financial perspective, this had been a very good year for MileagePlus. Cash flow has grew more than the other years. So do we say that it's an excellent year for the whole industry? Certainly not. For United Airlines as a whole, certainly not. But the consequence of this is the loyalty programs at the moment have definitely cash and the power to be able to drive the recovery of the airlines. So those entities and those people running the loyalty programs are the one using this power to implement new features. For instance, targeted awards. They want to target very specifically some new customers. Redemption expense control. They want to ensure that the points you still have in your pocket, and this means a liability for the loyalty program at the end of the day, because someone will use the points. We can somehow, with marketing features, control the way the points are used. So that the airlines again is going on the path of the recovery. So what are the key takeaways when we get out of this business analysis? Loyalty programs from now on will actively invest to drive the post-pandemic airline recovery. So they are the engine. What do they request from us, Amadeus loyalty program? They request three big family of features, a new wave of loyalty tiers. So they want to have an advanced way to segment their customer base. The customers of yesterday are not the same as the customer of tomorrow. And we need segmentation to smartly target them, to propose new alternatives, new benefits to customers. Okay. Non-air partners, I told you this is super important. Everybody understands now that you need to diversify your business and you need this ecosystem to be vivid and flourishing. And then dynamic rewards. We want, at the moment of truth, whenever you are shopping for your ticket, to push some offering to you. We want to say, okay, maybe this ticket is not the cheapest one, but look at how much points you would get if you buy it. And for this, we need our system, the loyalty backends, basically, to be able to answer very actively. So real time is super important in order to compute and advertise at shopping time. So from an IT perspective right now, let's deduce what are the consequences for Amadeus. We need to boost our developers' efficiency to decrease time to market. Every minute a developer at Amadeus Loyalty is spending doing some code, he or she needs to focus on implementing features, not writing a query to a database, not pushing an event to a pipeline. So we need platform and middleware to protect our developers, make them super efficient. Second, we need an open ecosystem. We need to leverage internal teams at Amadeus, external synergies as well, other companies to come to help us develop new feature with us. So we need modularity. And then real-time performances, again, talking about database, we need very strong and enterprise-grade performances to enable interactive use cases. Long gone are the days where loyalty programs were back office application. We need that loyalty to be available on the front of the shopping websites. Okay. So with this in mind, we took benefit of the challenging months that we went through to reflect at Amadeus Loyalty and think, what are our customers expecting from us? How can we help them? And we decided to create the Open Loyalty platform. So the goal of the Open Loyalty platform is to boost the developers' efficiency and to enable very straightforward ecosystem interactions. So what is it made of? Basically, it's made of modules, very small modules that are doing our loyalty business. Those modules can listen to information or push information into a loyalty event hub. An event hub is a highway of events, and basically every time a resource is updated, so let's say a member gets upgraded to a new gold tier level, that information will go through the event hub, and anybody in the company or out of the company interested into doing something, reacting, is free to do it. So that's the power of the event hub. You just have to listen and you get any information. Couchbase data store is basically the storage that powers, that's the engine, right? We have all the events, all the data stored into Couchbase, and we need the data store to accelerate all those events. So anytime you update the data in a database, that an event is automatically created and enters the event hub. Then not everybody is talking the event hub language, right? So you need an interface, and you need open data API. So the usual REST APIs that everybody knows to be there and to translate those signals to the external world. Then we plug those APIs to our enterprise service bus so that anybody in the world can consume those events. So you can imagine here all the usual suspects, web applications, our legacy loyalty modules. Let's imagine we cannot migrate them, all of them right now on the Loyalty Event Hub. We can use the Open Data API to translate messages, external partners, and basically any Amadeus application could talk to us via those Open Data API. What's interesting is that we are not the only one in Amadeus at Amadeus Loyalty to think about eventing, right? Other applications in Amadeus are creating their own event hub. For instance, all the data lakes in Amadeus could be fed very easily via event hubs. But what's interesting right now is that instead of going to the other event hubs via APIs, we could totally now be free to plug event hub directly one to the other and have a very efficient and direct highway for events to be efficiently pushed from one hub to the other. And now let's be futuristic. Our project at Amadeus is to build what we call the global event mesh, which is a mega event hub in which any meaningful event of the company would be pushed. And at the end of the day, we would open this global event mesh to the external world. And again, share with external partners our events, make data exchange even more simple, powerful, and fast. So, and now before I give the floor and the mic to Eric, let's focus on this event hub. So the circle, actually it's not a circle. So let's zoom in. I told you, we have a loyalty external API that is here to open our event hub to the external world. And let's take a look at what happens behind this API. So first of all, we have a loyalty service mesh, which is a service bus in which API can come and go. Okay, that's everything that you know, REST APIs. And we have our modules that would be plugged here. So that means that our new microservices, let's call them that way, would be plugged on REST APIs and would be able to be called or to call external services via REST API. That's the design that everybody knows, right? What's a little bit more new is the resource manager. The resource manager it's an optional database that we propose to our developers at Loyalty Amadeus. It's protected by a data API. So let's imagine let's consider it's a database, but instead of contacting this resource manager via service calls, SQL, for instance, ODBC, JDBC, that resource manager is protected by REST API. What are the APIs that we want to publish? Basically, from a high-level perspective, we want to propose our developers 3 big services. You can read a resource, you can write a resource, and you can search over a set of resources. And what happens? What's happening behind the hood? For every write that you're doing, so when you push a new resource, you need 2 buckets to be updated. First of all, you need the data bucket to be updated. So let's take again my example of a member being having a new tier, being upgraded to a gold tier. So when you want to say, okay, this guy benefits from a new tier, you update a first bucket, a data bucket, and you update another bucket that contains events. And you need those 2 buckets to be updated at the same time. So you need some kind of AC transaction to be sure that you update either the 2 of them or none of them. Then when you want to read, when you want to know which is the tier level of a particular member, you would use the read API. And then when you want to search, you would use a query service. And that query service would be updated thanks to a change data capture trigger from going from the data bucket to the query service. Now, what's happening starting from this events bucket? We need here as well some change data capture trigger. So every time an event is stored in the events bucket, we need a trigger to be raised, and we need an event to be created automatically. Again, the developer is not doing this. That's part of the platform duty, and we need an event to be pushed at least once on a pipeline. So you could imagine here various implementation, right? For instance, Kafka is what we're doing at Amadeus a lot, but let's not talk about the implementation right now. Huh? So what's very interesting at the end of the day is you would plug those modules again on the loyalty event mesh, and that would allow modules to either push or hear data via APIs on the dark blue highway, let's say, or they would be able to consume data out of the loyalty event mesh by just plugging themselves on the event mesh. And then at the end of the day, you understood it. We can plug as well this loyalty event mesh through our global Amadeus event mesh and send those events to the external world using using connectors, cloud connectors. Eric?
Hello, and thank you, Laurent. Okay, so we have our design. For now, it's just a whiteboard design and discussions. So let's take that. Let's implement it. In Amadeus, we have some internal framework that are built on top of Quarkus. So it's a Java framework. We are using, of course, Kubernetes to deploy the application. For the pipeline, as Laurent mentioned, we have Kafka that is already used in Amadeus, so it seems for us to be a natural choice as well for stream of events. And for the database, well, you may have guessed it, we went for Couchbase, which seems to be for us a natural choice here, providing that it offers document storage, it offers change data capture, it offers powerful querying capabilities with NQL and full text search. So we went for that, and we did the first implementation in local, first iteration, few iteration. And once we were happy with it, we moved to the cloud. So we had the chance to work on AWS on the managed Kubernetes service. And for the database layer, we got in touch with the Couchbase teams who offers us to work on Couchbase Cloud, which is their online service that allows you to easily deploy, manage, and cluster on any cloud provider. So we went for that. As a first iteration, we went for something pretty small, just to make sure that our design was working the way we would expect. So 3 nodes on the compute part with 2 vCPUs and 4 gigs of RAM each. That was hosting at the same time both the application itself and all the infrastructure that we have around it. So namely Prometheus, Grafana for the monitoring, Jagger for the tracing, and of course the Kafka cluster. And for the database layer, from the Couchbase Cloud UI, we just defined a simple cluster with 2 vCPU, 8 gigs of RAM, and 3 nodes, only running on the data service. No querying, no indexing, nothing else, just the data service for this part. We went here again to the simplest, just activating the public endpoint to connect the Kubernetes cluster and the Couchbase Cloud cluster, meaning that the link between the application and the Couchbase Cloud cluster was going through public internet. Last point, to benchmark our application, we went with Gatling injection that was kind of naively running at the beginning on a laptop, going through public internet to target the cluster. We did a few iterations, a few changes, and after some point, we managed to get some first results on that. So with an injection rate around 50 to 60 TPS, we managed to get 174 milliseconds of average response time and a 99th percentile of 325 milliseconds. Here, we are only focusing on the rest response time, meaning that everything that Laurent explained after the change data capture occurs were not taken into account into those measures. The last point I didn't mention before, for this first setup, we had small disks of 250 gigs of GP2 storage. Here again, it was just a first setup, just to make sure that what we had on the whiteboard was actually converted to something that may work on an actual integrated environment. So that was it. After a few days, few weeks of work, we had the first running application, first results. That was not that good, kind of okay. So we did some more iteration. And we activated private VPC pairing between the Kubernetes cluster and the Couchbase Cloud cluster. It was not a feature that was generally available at that time. So we worked with Couchbase team. So thanks to them for helping us on that to activate it. We upgraded a bit the nodes as well, the cluster. So with the bigger machines, so 4 vCPU and 32 gigs of RAM, 3 nodes on the Kubernetes cluster side, 3 nodes, the same specs on the Couchbase Cloud side. Still not the bigger machine that you can think of in terms of performances, but here again, we just wanted to benchmark to see how it was behaving, so it was okay for us. And still the same load injection, so using Gatling on a laptop, dedicated laptop. The last point we upgraded was the storage. So we went for a 5 terabyte of GP2 storage, not because we needed so much space, but simply because, well, we learned it a bit the hard way. We just read the doc, to be honest. And on AWS, the GP2 storage are limited. You get the IOPS, the number of operations per second you can do on a disk. That is directly dependent on the size of the disk. And you get the maximum IOPS you can get with GP2 storage, which is 16,000 IOPS, when you take a 5 terabyte disk or above. So we just went for the 5 terabytes. So we were not bothered with the IOPS limitation. We changed a bit the injection rate as well. We went from 50 to 60 to 100 to 200 TPS for around 1 hour after some tests and some trials, which seems to be for us a good compromise between what we could get on this hardware and what we could expect to begin with on our application. And here we got an average response time of 186 milliseconds, 99th percentile of 725 milliseconds, which, well, it's way worse than previously. But let's not be too pessimistic here. The problem was not on the application side anymore. Every metrics was green. The CPU was okay. The RAM was okay. The disk was okay. The issue comes actually from the injection itself. And as I said, we were naively using a laptop at the beginning. So we just changed that. The laptop was not powerful enough to manage to handle the traffic. So we went to AWS Cloud 9 injection. So AWS Cloud 9 being a an online IDE provided by AWS that allows you to code directly on a dedicated virtual machine. So we set up everything on AWS 9, did the same test again, same hardware. We just added another small hack on the cluster, on the Couchbase side cluster. We upgraded the number of writer threads. Until now, it was a default value, which was 8 for all the previous runs. And so this setting is not available on the Couchbase Cloud UI. It's something that we had to work with Couchbase team to get it upgraded. But we forced it to 64, which is the maximum you could get. Here, we still the same injection pattern, 100 to 200 TPS. A few hacks in the code to make some stuff better. We finally managed to get an average response time of 44 milliseconds and a 99 percentile of 584 milliseconds, which is still quite high, but that's explainable by the application itself, where we had some garbage collection storm and stuff like that happening from time to time. So we know that we have still room for improvement, but we are already much more comfortable with those figures. Now that we had that, we were okay with that. We wanted to see a bit what we could get just with the managed services counterpart of it. So for the compute, we went for an AWS Lambda with a Node.js application running on it, DynamoDB for the storage, and Kinesis for the streaming. We were pretty much convinced that we won't be bothered by the 100 to 200 TPS here. So we even changed the injection pattern and went for an injection from 0 to 100 to 1000 TPS, sorry. Same time, 1 hour or 1 hour and a half. And here, well, as we could expect, we get an average response time of 41 milliseconds, a 99 percentile of 106 milliseconds, which shows that it behaves more predictably, and more it's more stable in time. All in all, we were speaking of Smackdown between cloud-agnostic and managed services. Do we have a clear winner here? Well, we don't have a unanimous decision, and it will depend on several factors. If we talk purely about performances, the response time is more or less the same in both cases. So for the average response time, I mean, the stability is another part. You have around 40 milliseconds in both cases. Where the managed services really shines, it's on the scalability. Here, you don't need to bother about provisioning the hardware and to know how much traffic you will have. The managed service will update for you and scale automatically for you, which is hardly doable on the cloud-agnostic counterpart. In terms of developer experience, here we are speaking only for Amadeus developers. As I mentioned, we have an internal framework built on top of Quarkus, so it's something that we are used to work with. We work on it every day. We are a bit stuck with a few languages. We have Java for this one. We have a bit of C++ and Python, but that basically it. And the release cycle is still a bit heavy. It's getting better, but it's still a bit heavy. On the managed services side here, well, you have the freedom of language, and you're basically one Google search away from solving any problem you may face, which is really a good point here. And where it really shines on the managed services side is the plug-and-play ecosystem. In terms of system capabilities, you will have a managed service to do basically anything you want, whether it is sending a mail, if you want to send an SMS, if you want to store data, to make a full text search, anything, you will have a managed services that exist. You may find the same features available in the CNCF landscape, but it will require a bit more effort to plug everything together and to have a complete application using cloud-agnostic flavors. However, if we compare purely Couchbase versus DynamoDB, because it was the database here that was one of the main point of the comparison, well, Couchbase will be definitely more powerful than what you can get with DynamoDB. With an equal, with full text search, everything that you get out of the blue on Couchbase that you don't have only with DynamoDB. You need to have more managed services to have the same level of features. And last but not least, actually even the most important for us, with managed services, we would be vendor locked in. With Couchbase, we can deploy it on premises, we can deploy it on Azure, anywhere else we want, it would be okay. In terms of cost of ownership, I didn't mention it earlier in the slide, but we also did some measure here to compare both. And if you get a stable, really high traffic all the time on your application, you will pay more at the end of the day with managed services rather than a provision hardware that you have on the Kubernetes. On the other hand, though, if you have really low traffic most of the time and some big surge of traffic from time to time on the Kubernetes, you will need to provision Kubernetes plus Couchbase Cloud. You will need to provision for the high traffic that you have. And these resources will be allocated for almost nothing the rest of the time. Whereas on the managed services side, it's a pay-as-you-go way of working. So you will pay less at the end of the day. And you may have a bit more FinOps customization possible on the managed services side than what you can get with Kubernetes and Couchbase Cloud. So do we have a clear winner here? Not really, but for us, still the winner is Kubernetes and Couchbase Cloud for the different reasons I just mentioned here. So we wanted to iterate a bit over on that. We were okay with the figures, but we know that now we will work with Couchbase, with Kubernetes and our Java application. So we went back to our whiteboard. One of the big things that we tested in this first iteration and this first benchmark was Couchbase transactions. As Laura mentioned, we were receiving a REST request, writing both the data and the event in an ACID transaction to make sure that when one is persisted, the two are persisted, or none of them are. So this was a first approach. We changed a bit the way we were thinking, and whenever we receive a write request, we say, okay, why not just insert an event? We will have still the change data capture that will occur on the event bucket, still have at least one mechanism, the reordering process and everything, and send it to Kafka. Before going to the real loyalty event mesh where the modules can subscribe to them, we will just persist the data in the data bucket, meaning that you don't need any more of the transaction when you do the write request. You don't need, we can use them for some particular cases that we already identified in our flows, but in most of the case, we can bypass the transaction and just insert one event at a time. So we did a few more iterations on local development, and we pushed again our changes to a cloud provider. This time we went on Azure, and we went on OpenShift cluster, an OpenShift cluster, which is actually our test OpenShift cluster. So we are not alone anymore in this cluster. We have all the Amadeus application that is running on it. And for the Couchbase deployment, we are not using Couchbase Cloud anymore. We are using our own way of deploying the cluster, and well, our own ways to deploy the cluster, because we did a few setups just to compare a bit the impact of the hardware and of the setup on the performances. So we changed the CPU from time to time, the RAM, the number of writer threads. We did some tests using a single availability zone or several availability zones. And of course, as in any cloud provider, when you upgrade the VMs that you are using, you get more or less IOPS. And here we did all the setups. We ran the same kind of injection, so the same Gatling script we are running. And we did the comparison between the design with the ACID transaction activated and the design with an eventually consistent flavor, where you just write the event and not the data directly. If we need to compare, we don't have a comparison, an exact comparison between the setup on Couchbase Cloud and with our own way of deploying, because the hardware is not exactly the same. We have a bit bigger machines than what we have that we had with Couchbase Cloud. But even just as we can guess that the performances are still a bit better than what you get on Couchbase Cloud. And this is mainly for one reason. I mentioned earlier that we were using GP2 storage on Couchbase Cloud, which is LAN storage compared to here with own way of deploying the cluster. We have local SSD storage. So we don't have the latency of the network on the storage. So of course it will be better. So for the RC transaction counterpart, we managed to reach an average response time of 26 to 30 milliseconds, depending on the setup, on the hardware that we have. And where it really starts to begin to be interesting is with the eventually consistent flavor, where we are getting closer to the 1-digit average response time. You still see from time to time the 99 percentile that is quite high, but as I mentioned, we still have a bit of garbage collection storm that happens from time to time. We know that we have some features that we might improve in the application, that we may work on the future. And it's not something that seems blocker for us right now. So we are pretty happy with this result. We will keep on investing and to tune our application to get to the 1-digit average response time. And we are still pretty confident that we will get better on Couchbase results later on.
Okay, so key takeaways, 3 of them. First, as any engineer knows, the best design pattern is called, well, it depends. And we've shown this in the previous slides. So don't have a preconception, just get out there and test, right? Any exploration is worth it. So, and we hope that we've shown, especially for Couchbase, that okay, Couchbase is well known for being a super efficient cache key value store, but it can be used as your Swiss Army knife database of choice as well. Why not testing transactions? Why not testing change data capture? Couchbase can be very efficient in those unusual, let's say, use cases out of the very well-known sweet spot. So just test. And then we hope that we've shown you how Amadeus is doing innovation. So we don't do innovation for the sake of just innovating or for just architecture or technology. We focus on our customers first. So we like to know their business, their challenges, and then once we know this, we work backward. We go on a whiteboard and we design bold product visions. And when this is defined, and only then we explore radical options. How can we implement that vision? Here again, our suggestion is don't limit yourself. Don't waste your time. But if you think it's worth testing managed services, if you think it's worth comparing cloud providers, just do it. Harvest metrics, know exactly what you need to gather as data. And once you have the data, make educated choices, right, in order to iterate and to move further forward. Here in Amadeus Loyalty, we like to optimize for long-term growth, and we want to favor this over short-term revenue, but your mileage may vary. So as a company, as a team, as a group of people, you may have different strategies, but just discuss and just use the data in order to iterate. And then last but not least, if you think this is interesting, maybe you may want to join us. So just click on jobs.amadeus.com and see all the jobs that we have for you. See you soon.